Welcome to an introduction to Kubernetes. This is the 5th lesson in the series, and we're going to talk about pods. At this point, we've really been in a lot of theory, and we haven't been doing a whole lot of action. Well, for the next 2 lessons, you can expect to exercise your newly created Kubernetes cluster and have quite a bit more action. If you don't know what I'm talking about, check out lesson 4, where we go over the many ways for all the different OSs to install a local Kubernetes cluster to use. So enough about that, let's talk about pods. Today we're going to learn not only about what a pod is, but we're going to learn to create, update, and delete a container using the command line tool kubectl. This is the main command line tool used to interact with your Kubernetes cluster. Let's start with the basics of what a pod is. A pod is a collection of tightly coupled containers. These containers run as if they were on the same machine or VM. For simpler, they share all the same resources and constraints, including network, storage, and memory, and they communicate with each other like they were on the same machine, aka localhost. The pod is the smallest schedulable unit in the Kubernetes ecosystem and is the backbone of pretty much every other construct. First, to clarify, most people think of Kubernetes as a container scheduler. But that's not quite true. While in the end it might be safe to say that it schedules containers, it's only indirectly through the concept of the pod. As a pod does consist of one or many containers, in the end you can consider that it's scheduling containers, but Kubernetes itself is not really worried about containers. And this is important to understand for many reasons, but to be honest, that is going well into the inner workings of Kubernetes and not really for this class. Also, whenever you define multiple containers together in the same pods, you have to remember that all resource constraints apply evenly across the containers. So if you set the max memory or CPU of a pod, this is for all the containers within it. But enough of that for now. We want to be able to run one of these in our cluster, one of these pods. I did say we were going to do a little less talking, right? So let's just jump into doing it. My last warning before we do this, we're going to look into creating a pod by itself. But there are many constructs that should be used instead of the pod directly, most notably the deployment and replica sets. But we're going to discuss those in further details in future lessons. It's important to be familiar with pods, but you will almost never want to run and manage them directly. Pods don't heal, they don't scale. A pod is going to run on a node until it is complete or is stopped by the user or encounters an error. This pod won't be rescheduled and it won't repair itself. But we're going to touch back on this a little bit later, and we're going to do some experiments to really understand this concept just a little bit better, and we'll further develop this concept with the idea of the deployment. But until then, just remember, we're running a pod. Now, before we run a pod, let's check to see if any are actively running in our cluster. To do this, we're going to simply use kubectl git pods. That's it. This will list all of the pods in the default namespace. We're not going to worry about namespaces just yet, and so just forget that I said anything about it for now. We'll talk more about namespaces later. So let's fix this. We don't have any running pods, and we want to run a pod. Now, for most things, you can run the kubectl create command. But that doesn't work for pods. And while it might not make sense to you right now, it's fine, it's okay. I promise it will make sense in the future. Another thing to note here, I know I always harp on the declarative side of things, but to keep it simple, just for right now, we're going to do it an imperative way. Don't worry, we're going to fix that at the end of this video. kubectl has this great command called run. It's mostly useless in production unless if you're fixing or trying to debug a deployment in a bad state. And even then, it's probably not the way to go. But it is great when you are developing and learning. So let's run a pod using the kubectl run command. The run command is really quite simple to use. kubectl run, and then give it a pod name. And then dash dash image equals, and in this case, we're going to use nginx. Now let's break down what this is doing. We're running a pod in the default namespace. We can declare a namespace if we'd like, with the name my-pod. The pod will be created with one container based on nginx:\latest. That's it. Let's check and see if it's running. We can use the same command we used earlier, kubectl get pods. There you go. Your pod is running. But let's understand a little bit more about this. First, we're going to learn another flag for the kubectl command line tool, and that's going to be the -o, or -- output. This command lets us change how the kubectl command prints out its output. It's super powerful, and kubectl by default does not print out all the information. As there is a lot of information, most of the time this is good because we just want a high-level overview. But sometimes, like right now, we would like a little more information out of kubectl. So let's run kubectl get pods, but this time we want to pass -o wide. Wide is an extended format, but it doesn't stop there. Now run it with -o YAML, or you could do -o JSON. It even supports a tech called JSON path, and that we're going to learn about JSON path later. For right now, and most of the time, -o wide and -o YAML are the most effective. Let's dig deeper into the pod that we deployed. So run kubectl get pods my-pod -o YAML. You're going to see all of the information of your pod. And if you scroll down to the bottom, there's some information we're talking about. And here you're going to get to see a lot of good information about your pod that's running, including the last section, which is called a status. Here, there is quite a bit of information that is going to be useful. You will note that pods have 6 statuses: pending, running, succeeding, failed, unknown, and container creating. Pending means that while the cluster has accepted it's between scheduling and downloading images. Running, succeeded, container creating, and failed are all fairly self-explanatory. And unknown means that Kubernetes can't quite determine its status, and that's a topic for another time, as why Kubernetes might not know the status of your pod is a little complicated, and there's several reasons it might not. There are 2 more commands we should know about when it comes down to understanding what is happening with our pods. The first is the describe command. Let's use it now. kubectl describe pod my-pod. This is going to give you a lot of really good information, including events from the kubelet. The kubelet is the thing that you're going to learn more about later on in this course that is responsible for talking with the container runtime on the worker nodes. When debugging and troubleshooting, this describe command is one of the first things that I look at. The next thing that you can use other than describe is logs. Logs are super easy to get. All you have to do is kubectl logs my-pod. One note here, and we'll dive more into this a little bit later in this lesson, is this command works great for a single container in a pod. But what if your pod has more than one container? Well, don't worry, there is a command to dictate which container you would like the logs for, and that's the -c. So we have a pod that's running, but we'd like to stop it. Let's just delete it. It's simple. kubectl delete pod my-pod, and that's done. It is deleted. Now, while this is great and all, we really want a manifest that describes this pod. This is no problem. We can do this easily. On both the create and the run commands on the kubectl, you can run it with the --dry-run equals client flag. In conjunction with the -o YAML flag, this will create a manifest for your pod without applying it to Kubernetes. So let's do that now. You can see here with this command, I am piping it into a file called nginx-pod-YAML. This will make a file for what we deployed earlier without actually deploying it to our Kubernetes cluster. The best part, at this point, you can edit this file and use it as a starting point and then deploy it using either kubectl create-f nginx-pod.yaml, or you can use my preferred and use the apply-f with the name of your YAML file. Okay, now up to this point, we have only run a single container. Let's fix that. I have made a multi-container YAML file, and you can actually just run this command here, and it will run a pod that has multiple containers in your cluster. Now, how many containers does it have? Well, actually, this is really easy to tell. You can either look at the manifest file if you'd like, or you can just run kubectl get pods, and here in the ready column, you can see that this pod has 3 out of 3 containers running. You can also run the describe command as well as pass the -o YAML or JSON to see more information on your running pods. But that's not the only information we could get or want to even get about a given pod. And let's get the logs from these multiple running pods. And now getting logs is still quite easy, even though multiple containers are running. Now, again, a common mistake I see here is kubectl get logs. There is no get. It's a typo that I still make today. The log command only works for pods, so we don't have to get logs for a pod. All we do is kubectl logs. Now, if you have been following along, you are thinking, but there could be a few containers running in this pod. And you would be right. There's 3. If the pod only has 1 container, as it should, you don't have to pass any arguments. But if it has multiple pods, you're going to have to pass the -c command with the name of the container you are wanting to get. This being said, you can also pass the --all containers equals true, and that will return all the logs from all the containers inside of a pod. Now, you can check out all the flags you can use in conjunction with logs, but the most important ones to know about is the -p to get the logs of a previously terminated pod, and the --tail and the --sense. But I'll let you look into those further, as it's really useful to read the documentation on those. One last thing, something that is really extremely useful. You can exec into your pods or containers just like you do with the Docker command line. Now, I'm not going to cover all the flags or options, but understand this works mostly like you might expect it to. And how would you expect it to? Well, you might want to get inside your pod and poke around to see what's going on in this isolated container. And to do that, it's very similar to the Docker command line. kubectl exec the pod -c for your container. Now, there are 2 main ways to run this. Either a single off command with the --, or you can use the flags -it and get an interactive terminal inside your pod. Remember, if you have multiple containers, you need to pass the -c flag to specify which container you'd like. If you're only running a single container in a pod, you don't need to worry about this. And that is the fastest crash course on pods. Now, don't worry if that does not all make sense just yet. It will. It will in time. That being said, while in general we don't manage pods directly, it's really the building blocks of almost everything else we are going to be doing, so it's really important to understand pods well. The next lesson, we are going to learn some of the tech that is built on top of the pod, and it's going to enable easy management of the pods. And this is called deployments and replica sets. So please go ahead and join me in that and learn just a little bit more about how to manage pods in Kubernetes.